Welcome everyone, and welcome to the Game Designer Explainer for your Cambridge Mathematics exam strategy. Today we are targeting syllabus code 0580, and we are going to absolutely level up your answers for one of the trickiest, most misunderstood topics on the entire paper: bearings. Have you ever wondered how ships, planes, and explorers navigate vast, featureless oceans or open skies with absolute pinpoint precision? It's not magic, guys. It is the mathematical geometry of bearings. And more importantly for us today, it's the exact same logic you need to secure top marks on your exam. We see it every single year. We've got two types of students. Let's call them Alex and Sam. Alex is the type of student who overloads the exam paper with raw mathematics facts, just dumping numbers and chaotic calculations all over the page with zero analysis, hoping the examiner will somehow find the right answer in the mess. Sam, on the other hand, rushes. Sam sees the question, panics, goes too fast, and completely misses the specific command word requirements of the question. You'll see their flawed answers, covered in red pen marks, transformed today. By the end of this explainer, each paragraph of insight is going to unlock a new level of exam mastery for you. Let's dive in.
Here is our strategic roadmap for today's explainer. Section 1 is the evolution of direction. Section 2 is three-figure bearings explained. Section 3 covers calculating back bearings. And Section 4 puts you to the test with real-world navigation challenges. We are going to decode this step by step.
Section 1. The evolution of direction, from sailing ships to high-speed travel.
To truly master the exam questions, you have to understand why the system exists in the first place. As human beings began to move faster across the globe, the need for absolute directional precision completely transformed the way we navigate. In Era 1, the early days of sailing, basic compass directions were enough. You had north, south, east, west, and the midpoints like northeast or southwest. But as speeds increased and the margin for error shrank, extra points were added. Midway between north and northeast became north-northeast. This gave us a 16-point compass in Era 2. Then, that was extended even further to an extreme subdivision of 64 points. Can you imagine being a sailor trying to shout those complex, tongue-twisting directions in the middle of a raging storm? It was pure chaos. Eventually, the world realized that as travel speeds increased, slicing the compass into tiny verbal wedges just wasn't reliable anymore. We needed a completely new mathematically precise system to avoid disaster. This historical shift is exactly like what happens when you move from basic math to Cambridge IGCSE level math. The casual descriptions no longer cut it. You need absolute rigid precision to get the marks. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's look at exactly what that modern precision looks like.
Section 2. Three-figure bearings explained, the modern navigation standard. Pay close attention here, because this is where our student Sam loses massive points. The three-figure bearing system relies on two unbreakable rules, and these are exactly what the Cambridge command words are testing you on. First, north is always your zero, specifically written as 0, 0, 0 degrees. That requirement for exactly 3 digits is absolutely critical. This is why an angle of 45 degrees is always meticulously recorded as 045. If you just write down 45, the examiner brings out the red pen. Sam rushes and writes 45, completely missing the format requirement. Second, you must always measure the angle up to 360 degrees in a clockwise direction, representing one full rotation. It literally does not matter if your destination is slightly to your left. You do not measure counterclockwise. You still measure clockwise from north. This standardized rule is the bedrock of all modern navigation. To lock down these marks, I want you to think of the Peel framework. Normally that's for essays, but we adapt it for mathematics answers. Point: identify that the question requires a bearing from north. Evidence: measure or calculate the exact angle. Explanation: state that it must be measured clockwise. Link: present your final answers strictly in the three-figure format. When you structure your mental approach like this, you go from red cross marks to green check marks every single time.
Section 3. Calculating back bearings. How to get home. So, you navigated perfectly into the wilderness, but how do you return? This is the classic Part B of a Cambridge exam question. This is where the concept of a back bearing comes in. If the bearing of point B from point A is known, let's say you mapped the exact angle from your base camp to a mountain peak, how do we calculate the exact bearing to get from the mountain peak back to base camp? Notice the language, from B. The word from is your command word trigger. Wherever the word from is, that is where you draw your new north line.
Our other student, Alex, completely ignores this, overloads the page with random trigonometry, and misses the simple geometry the question is actually asking for. To solve this and grab those top marks, we rely on a beautifully simple geometric method. Let's rewrite Alex's chaotic answer live right now using our mathematics success blueprint. Step 1. Draw your parallel north lines. Draw one at your starting point A and draw one at your destination point B. Never try to do this in your head, put it on the paper. Step 2. Spot your alternate angles between those two parallel lines. Remember from your parallel line theorems that alternate interior angles, sometimes called z-angles, are exactly identical. This is the evidence you show the examiner. And step 3, apply the 180-degree rule by simply adding or subtracting. This structured step-by-step approach is what transforms a chaotic, overloaded answer into a clean, logical progression that examiners love. Let me explain exactly how that math plays out so you never second-guess yourself in the exam hall.
Here is how that third step brilliantly plays out on paper. If your starting initial bearing is less than 180 degrees, let's say it's 135 degrees, you simply use your alternate angles and add 180. So 135 plus 180 gives you a back bearing of 315 degrees. Boom, full marks. But what if you start with an initial bearing that is greater than 180 degrees? Say it's 245 degrees. If you try adding 180 to that, you're going to end up over 360 degrees, which makes no sense on a compass. So instead, you subtract 180. 245 minus 180 gives you 65 degrees. But wait! Think back to our Peel framework and the rules from Section 2. How do we write it? Yes, 0, 6, 5. We always adhere to those three figures. If you write 65, you lose the final mark.
The sheer elegance of this system comes down to a single magic number, 180. Geometrically, it represents a perfect half rotation. It literally means to turn completely around and face the opposite direction. By anchoring all our return math to this single perfect half circle, we eliminate any guesswork. When you see a back-bearing question on the 0580 paper, the number 1080 should instantly flash in your mind as your primary tool. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's put these theories to the ultimate test.
Section 4. Real-World Navigation Challenges. High-Stakes Mathematics. It is time for our interactive workshop. Get your pens ready.
Imagine you're sitting in the exam hall. You turn the page, boom! You're hit with a massive word problem about a climber standing at the very top of Mont Blanc, surrounded by freezing winds. He's trying to map out the surrounding ski resorts far below, using only his compass bearings and visual distances. This is a classic Cambridge context-heavy question designed to intimidate you. Let's break it down.
Okay, challenge 1, data scan. You have a 60-second mental timer starting right now. Look at this complex data table. Based on the climber's records, we have Val d'Isère at 30 kilometers on a bearing of 082 degrees, Les Aux at 40 kilometers on 135 degrees, and so on. In the exam, you need to extract the core trend immediately. Using this data, you will often be asked to draw a scale diagram, say 1 centimeter equals 5 kilometers. Don't let the real-world context distract you from the basic math. By setting a zero north point for Mont Blanc and mapping these angles out perfectly clockwise with your protractor, we mathematically determine the exact layout. If the question asks for the bearing of La Plonge from Val d'Isère, you can draw the line, measure the distance, and plot the journey straight to La Plonge without ever stepping off the mountain. Just remember, precision with your pencil and protractor is where the marks are won or lost here.
Next up, we have an even higher stakes scenario, the coastal rescue. This is a life-or-death situation involving a coastal radar station coordinating vessels at sea. Examiners love ship and radar questions because they allow for intersecting lines and complex multi-step logic. Here is your challenge to find the flaw. The radar station picks up a sudden distress call. A sinking ship is 50 kilometers away on a bearing of 345 degrees. Simultaneously, a lifeboat is 20 kilometers away on a bearing of 220 degrees. The station needs to direct the lifeboat to the ship. Imagine Sam's flawed exam answer reads, I drew a line from the ship to the lifeboat and measured the angle as 75 degrees. Where is the fatal flaw? Your 60 seconds are up. Here is the examiner commentary. Sam forgot the command word context. The lifeboat has to travel to the ship, so the bearing must be measured from the lifeboat. You must establish a brand new north line at the lifeboat's position, draw the connecting route to the ship, and measure clockwise from that specific new north line. Furthermore, Sam didn't use 3 figures for the 75-degree answer. It should be 075. See how quickly marks evaporate if you aren't vigilant?
Our final scenario shows why modern aviation relies completely on this exact mathematics. Imagine an aircraft gets diverted mid-flight due to an emergency. This is the ultimate test of your speed and accuracy under pressure.
Welcome to Challenge 3's Speed Writing. The aircraft is 210 kilometers from Airport A on a bearing of 065 degrees. It's diverted to Airport B, which is 130 kilometers from Airport A on a bearing of 215 degrees. You have a 30-second mental timer to visualize the perfect peel paragraph. Ready? Go. Think about the point. We need a scale drawing from a central north line at Airport A. Think about the evidence. Plot the 210 kilometers at 065, plot the 130 kilometers at 215. Think about the explanation. You connect the aircraft's current position to Airport B and measure the new angle clockwise from the aircraft's local north line. By applying these standardized rules, air traffic control and you, the top-tier student, can calculate the precise new bearing the aircraft must immediately take to safely reach the runway before running out of fuel. That is a full-mark answer.
So, as we wrap up, I leave you with this thought. If your compass fails, can you trust the geometry to save you? What we've discovered today is that these aren't just dry numbers, they are mathematical lifelines. To guarantee your top marks, remember our complete answering system. Number 1, command word decoding. Always look for the word from to know where your north line goes. Number 2, peel framework application. State your point, show your angle evidence, explain your clockwise rotation, and link it to a 3-figure format. Number 3, time management matrix. Don't rush like Sam and don't overwrite like Alex, just follow the geometry. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to Ace the Exams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep exploring, keep questioning, and I'll see you in the next explainer.